Energy supply is becoming an increasingly important social issue worldwide. The constantly growing demand of industrialized countries alone can only just be covered. As a result, old power plants are operated for too long periods of time, and new forms of power generation are quickly developed. Economical power distribution represents a great challenge. New paths are being taken in Benheim in the Alsace region. Roquette is one of the world's largest starch manufacturers with a very high energy demand of 100 megawatts. However, they pursue a different approach. The key word is geothermal energy. Energy direct from the Earth's interior. The first test drillings were made as early as 2012. The drillings are aimed at reaching a tectonic fault zone, where the granite base layer meets the prevailing bunter sandstone. The temperature difference in this fault zone can be used as a geothermal well. Again, the central question is how to transport the energy from the well to the consumers. The distance between the well in Rittershoffen and Roquette in Benheim is 15 kilometers. This is where the specialists of FW-FERNWÄRME-TECHNIK GmbH come into play. The know-how of FW-FERNWÄRME-TECHNIK is always in high demand when it comes to transporting energy over long distances, while keeping losses to a minimum. The route for transporting the energy of the geothermal well to a distance of 15 kilometers begins in Rittershoffen. The pipeline is maintenance-free and is laid underground over the entire length. The pipe system is subdivided into various sections. Thermal pre-stressing is of central significance in the installation of the district heating pipeline. The operations for pre-stressing the inner pipes against the encasing pipes are controlled and monitored in a container, specifically developed by FW-FERNWÄRME-TECHNIK GmbH. The installed pipelines are pre-stressed using a standardized procedure. The entire pipeline is subdivided into pre-stress sections. The pre-stress levels are specified in the FW drawing. The sections are calculated individually for thermal pre-stressing. A steam generator accommodated in the pre-stressing container can generate 120 degrees Celsius low-pressure steam, for example, which is conducted into the inner pipes. Thermal pre-stressing means heating up steel. The pre-stress levels in the pre-stress sections are controlled accurately to the millimeter. Once the desired pre-stressing temperature is reached in the inner pipe, the maximum expansion of the inner pipe is reached as well. The pre-stressing forces from the inner pipe are deflected into the ground via the encasing pipe. Concrete foundations to absorb the anchor forces are not required. In Benheim in the Alsace region, FW-FERNWÄRME-TECHNIK has implemented an environmentally friendly project for power generation and distribution. Owing to the vacuum in the ring space thermos flask effect, a steel case pipe DN250 with 70mm heat insulation, located inside the encasing pipe DN450, is only subject to a very little thermal loss. The pre-stressing temperature is approximately 120 degrees Celsius. The system is operated at 170 degrees Celsius. The anticipated service life is 50 years. The steel case pipe-in-pipe construction units are manufactured in the factory of FW-FERNWÄRME-TECHNIK GmbH in Cell. Steel-cased pipe-in-pipes for a wide range of applications have been manufactured here for nearly 40 years. Know-how, precision and experience in manufacturing steel-cased pipe-in-pipe systems, as well as an innovative approach for various requirements, are the core business of FW-FERNWÄRME-TECHNIK GmbH. This is how a very special district heating pipeline is created between Rittershoffen and Beinheim. By connecting Roquette to geothermal energy, fossil fuels can be saved. The many years of experience of FW-FERNWÄRME-TECHNIK GmbH in designing and prefabricating these systems have enabled the staff members to considerably improve their manufacturing expertise, which has significantly prolonged the service life of our pipelines. Le Havre, a second project implemented with FW-FERNWÄRME-TECHNIK GmbH at the same time, also relied on FW steel-cased pipe-in-pipes. The construction site is extraordinary. The groundwater level is very high in the estuary of the Seine. Buildings have piled foundations. Buried pipelines such as FW steel-cased pipe-in-pipe are practically laid above the ground, and the pipe systems are backfilled. A state-of-the-art waste incineration plant has been equipped with an additional turbine unit. Consumers are supplied with energy via FW steel-cased pipe-in-pipe. This pipeline also has an anticipated service life of 50 years. A double pipe system, inner pipe DN350, insulation 150 mm and encasing pipe DN700 is laid over a length of 3,000 meters, through which consumers are supplied with steam 270 degrees Celsius and 25 bar PN40. The FW steel-cased pipe-in-pipes are manufactured in Cell. Standard lengths, fitted lengths and pipe fittings are prefabricated for the specific project. All inner pipe welds are subjected to 100% radiographic testing. All components are transported from the factory direct to the construction site and are frequently laid into the pipe trench straight away without interim storage. Following assembly, the trenches with the pipes are backfilled. Due to the high operating temperatures, thermal pre-stressing is not possible in this case. The thermal expansion in the inner pipes is compensated by means of natural compensators, such as L-bends, Z-bends and U-bends. The compensators allow the pipe to move once the operating temperature is reached. After 3,000 meters, the connection is ready. FW-FERNWÄRME-TECHNIK GmbH has implemented yet another energy transfer route.